Hello class. This video lesson should help you out with abstract classes and interfaces. We're just going to discuss a little bit about each. First of all, abstract classes. Abstract classes are never instantiated. Their only purpose is to be used as superclasses. They're common in the API. You use them when a superclass is needed for a number of subclasses, but there will never be a need for an instance of the superclass itself. Abstract methods in an abstract superclass have to be implemented in any subclasses. They have to be implemented. Now, there are some interesting points about abstract classes. You declare them with the keyword abstract. You can't make objects with the abstract class. You can't use the new operator to run a constructor. You can only extend these classes. You can only create subclasses from them. Abstract classes might contain abstract methods. Typically they do, but they don't have to. And they can have non-abstract methods as well. Abstract methods are declared with the abstract keyword as well in the method header, as you can see here. But notice the key point about an abstract method: it has no braces and it has no body. It's strictly the method header line. Abstract methods have to be implemented in a subclass which extends the abstract class. If not, that subclass also has to be abstract. Abstract methods cannot be static. Even one abstract method in a superclass means that superclass has to be abstract. An abstract class can be a subclass of a non-abstract or concrete superclass. A method that's non-abstract in a superclass can be overridden as abstract in a subclass. And you can use an abstract class as a data type. Now, the textbook has an example of class number, which is the superclass for the wrapper classes for the numeric types, and it's an abstract class. Now, without looking at that, I wanted to carry on to interfaces. Interfaces. An interface is a class-like structure that classes can implement, not extend. They implement. Interfaces are intended when we have objects that exhibit common behaviors for comparison purposes. Interfaces can only have abstract method signatures and constants. No attributes, no fields. Interfaces are declared using the interface keyword. Here's an example of an interface called edible, which has an abstract method called how to eat. Notice there's no set of braces and there's no body, simply the method signature. You never have method definitions inside of an interface, at least not for an abstract method. Interfaces are implicitly abstract. You cannot directly instantiate them with the new operator. They must be implemented by a class with the implements keyword. Here's an example of a class called banana that's going to implement the edible interface described up above. Well, in order to do that, it has to provide the body for the method. It has to provide the curly braces and something inside to provide the body. That's called implementing. Once you've done this, you've implemented that abstract method. You've implemented the interface. Now, there's one very important one that we want you to take a look at. That's the comparable interface here. The comparable interface is commonly used for objects of the same type that need to be compared. If you want to compare two objects of the same class type, you can do that with the comparable interface. Many classes in the API are already implement the comparable interface. It has a method called compareTo, which has to be coded in order to implement the interface. An example is class string. As you know, we can detect if a class classes are equal. We can sort strings. We can sort an array of strings, and that's because it implements the comparable interface. Well, in order to code your own comparable class that implements comparable, you have to write your own compare to method, and you would use some code like what you'll see on page 515, lines 9 to 16 in the comparable rectangle class. Basically, you have to return a positive if the object implementing comparable is greater than the object you're comparing it to, or a negative if it's less, and 0 if they're equal. So let's take a look at an example. Last day, we worked on an example in class for class person, and we extended that to two other classes, hourly and admin. Well, we're going to modify that slightly. We're going to make the person class abstract, and we're also going to implement comparable for class person so that we can compare person objects in some way. And in fact, we're going to compare them based on their date of hiring, which would be this field here, the local date field. I modified the class a little bit. I took away the salary field and instead added a field int ID instead. And we also made all of these attributes protected instead of private. That means we could inherit them and that we can access these fields in subclasses without having to use the getter. So our getters were not needed because we made all of the attributes protected. That means they are accessible from subclasses of this class. Now, the other thing that we did was, in order for this to be an abstract class, why did it have to be abstract? Well, it had to be abstract because I added an abstract method here called pay. It's a void method, and it's going to actually print out the pay. Notice there's no body and no braces. Okay? Now, if I take this out, watch what happens if I remove this. Right away, Eclipse gives me a warning message here. Person must be an abstract class to define abstract methods. So it's telling me, hey, this class has to be abstract if it's going to have an abstract method. I also get the same error indicator down here by the abstract method. Message is, the abstract method pay in type person can only be defined by an abstract class. So I've got to put that abstract back into the class header line. So I'll do that. Now it's okay. Now we're also implementing the comparable interface for person. Notice the implements keyword. Well, we're going to compare them based on their date. And as it happened, in order to do the compare to here, the local date class actually is defined in the API with a compare to method. It does implement comparable in the API, so we can do it rather simply like this. But once again, I'm going to block that out. I'm going to comment that out just briefly for a moment. I'm going to add a block comment. And then let's take a look up here. Implements comparable person. Well, it doesn't really say anything about how we're doing it. So the reason for that is because comparable is actually in the local date class. That won't always happen. So I'll remove that again. Okay, so that's our person class. Just save that. And let's take a look at the admin class. Now, admin extends person. Well, if it extends person, which was abstract, it has to implement the pay method. And here it is. Notice we get the automatic override. And in this case, I'm going to work out the pay for an administrative employee as the monthly pay. We're going to convert the annual salary into a monthly pay and then print it out. But notice that we are now overriding, we're implementing that abstract method from our superclass person that we extended. Because we're inherited from class person, we have to flesh out or implement the pay method. And if I were to comment that out, This is the effect that I guess I wanted to show you. I'm going to block that out, black comment. And if you look up here, look at the message up here. I'm just going to hover over the message. Type admin must implement the inherited abstract method person.pay. Yes, it does have to do that. So if you forget to implement one of the abstract methods in a subclass, Eclipse will help you out with that. So I'll bring that back again by removing that comment. And then we have our toString method. So that's the end of that one. Let's look at the hourly class. I'll just make sure I save those changes. And we'll go back to the hourly class quickly. In the hourly class, I modified it slightly. We also have the int ID in the constructor now instead of the salary. It made no sense to have salary in the case of an hourly rated employee. So this is a much better class definition. And because we are extending person, we have to implement the pay method here too. Let's see how it's done. Here it is right down here. We've implements the abstract method pay that we inherited from person. And in this case, because it's an hourly rated employee, we're going to display the weekly pay instead of monthly pay for a salaried employee and administrator. So there we have it. Now, let's take a look at our HR program. Here's the program where we use those classes. We make a few local date objects, and then we slightly have to modify the definition for the constructor. I have to take out the salary. No, I added the ID number. 1001 is the ID number. Okay, and I discovered that with local date, we can actually do this. We don't even need to create a local date object. We can just say local date of, and that'll be just fine for a date. So those are our two admins, and then we have 3 hourly rated employees as before, except we gave them, instead of salaries now, they have ID numbers, 1010, 1011, and 1012. Then we're going to make an array again, but we're going to make an array of person objects that don't have any person objects at all inside here. These are subclasses of person, and that's okay, and that demonstrates polymorphism. An instance of a superclass can hold an object of type superclass can hold an instance of the subclass. Now, Burns is going to give everybody a 10% raise that's hourly, but he's also going to give a 15% raise to all the admin players, okay, all the admin employees. And so we modified this just a little bit from last week. We added an else block to increase the salary of admins by 15%. Very unfair, but that's the way it works. Now, look at this line. This line here, arrays.sort emps, that's our emps array. Well, this only works, this will sort them on hire date. It's going to sort them on date because that's the way we decided to implement compare to back in class person. Just briefly go back there just to show you that one more time. There it is. We're going to be sorting. We're going to comparing by the hire date, the date attribute, and this will sort them based on their hire date. Then we'll create an array list. We don't need these. Don't need those lines. And after the array list has been created from the array, Mindy Simmons is hired, and her employee number is 1013. And then we we slightly modified. We got rid of the one loop that we had, and we're just going to use actually one loop here to display all the employees after raise sorted by hire date. They should all come out sorted by hire date. That's what our implementing comparable did for us. So we do have to, however, if we want to run the toString method, we have to make sure that we cast to the right type of object. So we're going to detect our hourly rated employees with the instance of operator, and then we'll cast our variable P into a person variable into an hourly person. And then we'll do the same thing down here for admin. We'll cast. So when we run this, we get something like this in the output. They should all be in order by hire date. Notice Burns was hired in 1940. Smithers after him, and Mindy Simmons was hired last. She's the last one in the list. You'll notice too that their pays have increased. Burns and Smithers have gone up by 15%, whereas the hourly rated employees have gone up by 10%. Well, that's a little bit about how abstract classes and interfaces work. I hope that helps. Be sure you also try Liang's examples in the textbook. They're very good.